All right, so in today's video, I'm going to talk about the different options that you have when you want to control an AC wave. So let's say, for example, you want to control a motor for a pool, just like I have here in the background. You have two options. Now, depending on how much current the motor consumes, you can go with a mechanical relay like this one. I'm going to show a little bit closer later. Or you can use what's called a solid state relay like this one. Now, the advantage of this one is that you can PWM and it doesn't wear out as fast as the mechanical relay because you have no moving parts really. So let's go over if you decided to use a mechanical relay. Now, if you decided to use a mechanical relay, they usually come in these really nice packages, like these modules. And these particular modules have an input, ground, and VCC. Now, the reason for the input is because there is a control system here that you can add. Now, this is how the circuit is. And that input pin is actually the base of a BJT, right? You can also use a FET, but for this example, I'm just drawing it as a BJT. Now, this BJT, once the input is, let's say, if you're using an Arduino or some other microcontroller, let's say for simplicity, you're using an Arduino and the output of the Arduino is 5 volts. Once this is 5, it shorts this coil to ground, essentially applying 5 volts across the coil, actuating it. Now, the 3 different outputs here mean normally close, common, so let's put COM there, and normally open. All this it means is that when just how it's sitting here with no power applied to the coil, this common or this center tab here is connected to one of the 2 outputs here. In this case, this one is my normally common one. Normally close, sorry. So common normally is connected to this. When you apply power to the input here and this coil is energized, this will switch from common. Now common will be connected to here, right? So it'll toggle back and forth. Now, when using these, it's very important to know what kind of power you're going to be drawing. So obviously, you can use these over here. You can put 200 up to 250 volts, but your current is limited to 10 amps, right? So if you put more than 10 amps, you will fry this output side and it'll just break the circuit. Now, it's very important to remember that you can only put the 250 volts on this side, so essentially on this side of the circuit, and not on this side. If you put 250 volts on this side, you will instantaneously fry this part. So don't do it. Now, on the other hand, you have something like the solid state relay. Notice how the solid state relay doesn't have a common pin like the mechanical relay. The reason to use a solid state relay is basically you're using it as an interrupter. So if I were to draw it here, you're essentially interrupting. So you tie here. So this, let's just draw it, right? So you have a control circuit on this side, right? Which you can say from negative to positive, right? And you have a range that you can control this mechanical relay with. So you can control it with 3 volts up to 32 volts. So an Arduino can control this thing. And this is an LED to show you when the output is engaged. So you can connect this to ground like this. Oh, broke it. You can connect it to ground. And then this can go up to some type of Arduino pin, right? Arduino, right? To whatever pin. And then you can PWM this thing to control whatever output you want. Or you can just set it high and it'll just close the path. But the connections here are as follow. Let's say that you have your motor. You connect one leg of the motor here, and then it's a continuation, and then this will go to your motor, right? And then the other one will be like your line, your neutral line or your line 1. But your line 1 gets interrupted by your solid state relay, right? All right, so on my next video, I'm gonna be showing you guys how to make these boards from scratch, these printed circuit boards, and use JLC PCB to get them. And we're gonna be building together a sprinkler control system using either one of these guys or one of the mechanical relays. So if you guys have any questions about that project or want to give me any ideas, go ahead and leave me a comment. And if not, I'll see you in the next video. Peace.